How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to talk about determining the theoretical yield. Basically, how much stuff can you make with what you got? So our objectives will simply be just that. Determine the theoretical yield giving starting amounts or the limiting reactant. So let's talk about theoretical yield. What is that? Well, it is how much product should you be able to make given starting amounts of a reactant. In a perfect world, how much could you make given how much you started with? In reality, reactions aren't perfect, and you won't make 100% of what you should, right? Just think about grilling. If you're grilling, sometimes you drop a hot dog. Sometimes a hamburger gets in between the grates and get into the fire, and you lose that. And it turns out you couldn't make all the hamburgers or hot dogs you were supposed to be able to based on what you got, right? Chemists aim to optimize their reactions and get as close to 100% as possible, but sometimes there's side reactions, things that you're not trying to get to happen. So how do you determine what the theoretical yield is? Well, you must know the limiting reactant first, and if you don't know how to do that, you can watch the previous video. Then you got to do the stoichiometry based off of the limiting reactant. Once you have the limiting reactant, that's the only thing that you're focusing on. You ignore everything else. All right? So you remember that the balanced equation shows the mole ratio. So if they give you grams and or want the answer in grams, you'll need to convert using the GFM. Remember that. So here's an example problem. It says, given the following equation, how many grams of AlI3 could you create if you started with 1.5 moles of Al and 1.5 moles of I2? So for this, I like to use circle, boxes, and triangles. So they're interested in this. So that's this stuff. If you started with 1.5 moles of Al, so the Al is boxed, and 1.5 moles of I2. I'm going to put a triangle around I2 so that I can it gets a little messy, but it helps me. You could not do that. I'm just saying what works for me, okay? So first question is, what is the limiting reactant? So in order to figure that out, you got to go, all right, well, let me take a look at my reactants. So I have Al and I have I2, and they are in a 2 to 3 mole ratio. So now I take a look. They have 1.5 moles of Al and 1.5 moles of I2. So I just got to plug one of those in. I'm going to do it for Al. So 1.5 moles of Al is to how much I2? Well, X for this example would have to be, oh no, I didn't do this math. I think it's like 2.25 moles. So what's that tell me? Well, that's how many moles of I2 I need. So I look, well, I only have 1.5 moles of I2, so I don't have enough I2. That tells me that my limiting reactant is I2, right? Because I have less than what I need. So now I go, all right, well, I'm going to ignore everything that's aluminum, and I can look at just I2. So the next part is do the stoichiometry based on I2. So now I got to look at, all right, well, ignore the aluminum. Boop. I'm just looking at I2. So I2 to the AlI3 ratio is a 3 to 2 ratio. So now I go, all right, well, how much I2 do I have? Well, I have 1.5 moles of I2, and how much AlI3 could I make? Well, let's see. I cross multiply and divide. I get 3 equals 3x. So x has to equal 1 mole of AlI3. And I'd be done if it wasn't for the fact that they asked for my answer in grams. How many grams? So now I got to do 1 mole of AlI3 times the GFM of AlI3, right? So 1 mole of AlI3 is what, to do that I got to look up all that stuff. So I look up aluminum, which is 26.98 grams per mole, and I got to look up 3 times each iodine. So I look up iodine's mass and 126.90, so 126.90, and I do all that math and I get a math of 407.68. Grams is my final answer. Yeah, so that's how you do that. Here's another one, because repetition. 27 grams of nitrogen is reacting with 15.5 grams of hydrogen to make NH3. What is the theoretical yield? So, whoops, same process. So I go, all right, well, I got 27.0 grams of nitrogen. I'm going to put that up top. 27.0 grams of nitrogen and 15.5 grams of H2, and they want to know, well, how much NH3 could we make? All right, well, first things first, I got to use the moles of nitrogen and hydrogen. So I got to do a little conversion, right? So I do the GFM of N2, which is 28.02, and I divide that and I get 0.964 moles of N2. I do the same process for I2, except it's 2.02 as its GFM, and I get 7.67 moles of H2. So now the first question is, well, what is my limiting reactant? So I got to look at my N2 to H2 ratio, and I use the coefficients. It's a 1 to 3. So now I just pick one of those to see which one's the limiting reactant. I'm going to use nitrogen because no reason. 0.964 is to X. So what does X equal? X equals 2.89 moles, and that's going to be of H2 needed. So I look, well, how much H2 do I actually have? 7.67. So I got extra H2, which tells me that my N2 is my limiting reactant. So I'm going to do all my math based off of my limiting reactant. So what is my theoretical yield going to be? Well, I got to look at my mole ratio between my limiting reactant and my thing of interest. So my N2 to NH3 ratio is going to be a 1 to 2 ratio, and I got to use the quantity of N2, my limiting reactant. So I got to do 0.964 moles as to how many moles of NH3. Well, if I do that, my X is going to equal 2.89. I think. Did I do that right? No, I didn't. Sorry, wrong one. Ignore that. 0.964 times 2 gives you 1.928 moles of NH3. And I'd be done if it wasn't for the fact that they're giving everything in grams. So they probably want the answer in grams. So I got to times that by the GFM of NH3, which is going to be, 14.01 for the nitrogen plus 3 times 1.01 for the hydrogen. And I get like 17.04. And I multiply that and I get my final answer in grams of 32.9 grams of NH3. And that's how you do your theoretical yield. All right. So summarize. What is meant by the term theoretical yield? What is that? And how do you determine the theoretical yield when given amounts of reactants that you start with? Okay. So summarize that. Hope you found that helpful. I'll see you in class. And if I don't, then I'll be sad. So go to class.